All right, so this is unit 4, day 2 notes. We're just, as I said before, this top section these are the objectives that are being covered. Look at this. There's a lot of objectives being covered. A lot of times it's multiple objectives in one problem. So that's kind of like at the beginning of each day, that's what you're going to look at. You're going to look at the objectives to see all what's being covered. And if you see something in here that is being covered on Alex and you're not understanding, maybe come back into the video, sorry, and get a little extra help, and it'll hopefully help you and Alex. A lot of times this practice makes perfect on these situations. So let's go, and we're going to do the starred problems. Again, a lot of times with these problems, I give you a chance to kind of have some practice on your own if you need it. And again, you can look at on the Canvas shell, and on the Canvas shell, it's going to have the key. So, and if you can't read it, go ahead and print it out. It's uploaded in Canvas. Print it out, and then we can do it kind of together. So that's how it would be done if you were in class with me. All right, so the first one says, a tortoise is walking in the desert. It walks at a speed of 2 meters per minute for 5.12 meters. For how many minutes does it walk? This, believe it or not, this is and then you'll see it in Canvas. I mean, you'll see it in Alex as well. This is distance equals rate times time. Okay. And again, you will kind of notice those problems, especially once you start doing them over and over again. When you see it's riding a bicycle, and you'll see it in the next one as well. And the more you practice it, especially on Alex, you'll start to notice these. Distance equals rate times time. Again, they may or may not give you the formula, but you need to kind of recognize that that's what's going on. So if I'm using that as my kind of starting point, then I can basically substitute in what the answers. I can substitute in the numbers, and then whatever's missing, I can solve for it. So let me see. It said so the tortoise is walking in the desert. It walks at a speed of 2 meters per minute. So if they're talking about the speed of something, you should know that that's kind of like rate. That's the rate. Okay. For 512 meters, that is the distance. That's how long it's walking for. That's it says it's walking 512 meters. And for how many minutes does it walk? Again, that's time. We don't know what the time is. Okay. So we do have 2 times t. Again, you don't have to put those parentheses. You can put 2t, same thing. And then equals 5.12. I'm going to solve for t. Again, it could be 5.12 equals 2t. Divide by 2 on both sides. You would do the same thing here if you solve it that way. And this handy dandy calculator, Texas Instrument TI 30X2S, very, very, very useful. You will need this for all the math going up to pre-calculus. Please purchase one of these. They are so, so, so useful. You will need it, I promise. $12 at Walmart, around that. And you will use it. You will use it all the time. It is a very handy tool, especially when it does fractions, all kinds of different things. So please try to get one of these, okay? So I'm going to put in my calculator, and you can use it for math. Everything over math unit 1. So we're in unit 4, so we can definitely use it. You can use it on tests. So please, I'm just urging you to get it if you can. Okay. So I'm going to divide 5.12 divided by 2 and push enter. My answer here is 2.56, it looks like. Okay, so 2.56 is the time, and it says how many minutes. So basically, you're 2 minutes and 56 seconds. Got it? All right, 2.56 or 2 minutes. All right, so let's move on to this second one because it has a star next to it. Deshaun is riding his bicycle. He rides for 2 hours at a speed of 6.4 kilometers per hour. For how many kilometers does he ride? Again, that is a distance equals rate times time. Okay. So we are going to basically, again, substitute in. He's riding his bicycle and he rides for 2 hours. 2 hours is a time period. Okay. So we're going to replace that T with the 2. And he's riding at a speed of 6.4 kilometers per hour. Again, that's the rate. Okay. That's the rate he's riding. And it says for how many kilometers, that's the distance. We need to, they don't know what the distance is for that particular situation. So we are just going to multiply these two. 6.4 multiplied by 2, you get 12.8 as your answer. So the distance is 12.8, and it tells you here how many kilometers, so it's 12.8 kilometers. Okay? That is our answer there. All right, so let's go down to the next one with the star. A store owner has 65.5 pounds of candy. If he splits the candy equally into 5 boxes, how many pounds of candy will each box contain? With this particular one, yes, you can write an equation for this. For me, I'm just really kind of doing it in my head or thinking of how I can solve the problem as quickly as possible. If he has 65 pounds of candy and he splits them up equally into 5 boxes, what I'm going to do is 65.5 and divide that by 5. Because that's splitting that up equally. And then whatever answer I get out will tell you, because this is the total, it's going to tell me how many each box contains once I split them up into 5 pieces. So I'm basically just dividing there. So 65.5, and you're going to divide by 5, and I got 13.1. So basically, once I had a total of 65.5 pounds. If I split them into 5 boxes, I'll have 13.1 pounds in each box. Okay, that's my answer there. And I did want to kind of put a box up there to show you that's my answer. This one, try it on your own. The key will definitely be on Canvas, so use that to make sure that you are doing the correct or having the correct, let me turn this over, answers when you answer those questions. Please, if you have any questions, don't hesitate to come to my office hours, set up an appointment so that I can help you feel more comfortable if you need or whatever. Please make sure you're also in Alex and working on those problems and going back if you need a review, okay? All right, so let's look here. This is the second page. We are on the top, and again, it's hard really to read it here, but print it out. It's in your Canvas shell. All right, so Mr. Cook has a class of 14 students. He can spend $19 on each student to buy math supplies for the year. He first buys all of his students' calculators, which costs $127.40. After buying calculators, how much does he have left to spend on each student? Okay, so this is like multi-pronged, but I think we can figure this one out. So basically, he has 14 students, so we know he has 14 students, and he's allowed to spend $19 on each child. So 14 times 9 will tell me how much he's allowed to spend. 14 times 19, okay? So I'm just going to throw that in my calculator, 14 times 19. And basically, he's allowed to spend $266 on each child. All right, so that would tell me there. Then he says he first buys all of the students' calculators and he spends this much money. So now we have this much as our total. He's going to spend $127.40 of that money. Okay, so I'm going to take the 266. I'm subtracting $127.40 from it. And it looks like he'll have $138.60 left over. Okay, 138.6 is $130.60 left over. So now we need to figure out of what the leftover, after buying the calculators, how much does he have left to spend on each student? So if he has $138.60 left over, we have to divide that by the number of students, which is 14, in order to get our answer of how much that total is when you divide it by 14 students. So I'm just going to divide that by 14, and I get 9.9. So basically, my answer after all of that is he'll have $9.90 to spend on the rest of the students after he is finished purchasing the calculator. Okay, so again, it's not even that difficult. A lot of times with all the words, you get confused. Just take your time, and the more you do it, the easier it'll get for you. Okay. All right. So now we're going down to the this part where we're simplifying, and it kind of wants you to understand like terms. So if you have this u squared and this one has a u squared, these are like terms. You can combine them, which means add or subtract them depending on what the signs are. So what I'm going to do is I'm just going to take the coefficients, which is the number in front of the letter, and -2 here, +6, and kind of combine them. So when I combine -2 + 6, I get 4. And why can I do that? I can do that because they both have the u squareds, okay? So I got 4u squared when I combine these two, combining like terms. Let's try this. We have -5 - 6. So -5a - 6, we're just going to add or combine the coefficients. So in this case, it gave me -11. And then I'm just going to put the a after. Okay, so we're just combining like terms. We're just putting the coefficients, the number in front of the letters. We're combining them, and then we're just going to put the letter at the end. All right, try this one. 10c - c. And although there's nothing there, it's understood to have a 1. So basically you're saying 10c - 1c, which becomes 9c. Okay. Now this one here, 2y + 2x + 6x. You cannot combine them if they do not have the same term. I mean, the same coefficient at the end. I mean, variable, excuse me, variable at the end. Okay. You can only combine like terms, the ones with the x's. They're like terms. That is not a like term. So I'm just going to leave it alone. And then I'm going to find 2x + 6x, 2 + 6, 8x. That is going to be my answer. I cannot combine those two because one has an x and one has a y. When you're adding, you cannot, adding or subtracting, you cannot combine unlike terms. When you're multiplying, you can. And that's what you're going to see here using the distributive property. Okay? And I'll show you what I mean. So if you're looking at this one, we're going to distribute this -2 to every single term, which means distributing means you're multiplying. So I'm going to take -2 and multiply it by this term. Then I'm going to multiply it by this middle term, and then I'm going to multiply it by this end term. Okay? So -2 times -3y squared. You're multiplying the numbers. That becomes -2 times -3, +6. We're leaving the y squared alone. Okay? Now you're taking -2 times -6. Both negatives become a +12. Okay? And then -2 times 3x cubed. Multiply -2 times +3, it becomes -6x cubed. And why can we not put these all together? Why can't I add 6 and 12? Because they're unlike terms. This one has a y squared, this one does not. This one has an x cubed, that one does not. And these two are not the same. So we can't combine, we have to leave them separate. Okay? All right, let's go down here, see what we can do. All right, so same thing here. We're distributing, we're multiplying this number by each number inside individually. So -3, you're going to multiply it by -4y cubed. negative 3 times 3, negative 3 times u squared. And it's kind of going to be similar to what happens up here. Negative 3 times negative 4 cubed, y cubed is going to be positive 12y cubed. Negative 3 times 3, negative 9. And negative 3 times negative u squared, okay? Basically, the negative and a negative become positive, and now I'm just going to put 3u squared. And you can't combine any of those because they are unlike terms, so we're just going to leave them like that. Okay, last page. Here, same distributive property thought process, except you're going this way. We're multiplying 9 times u and then 9 times negative 11. When you see that minus in between, a lot of times you want to say subtraction, yes, but it means the second number is negative. That's all that it means. When you see that minus, this number is negative, okay? So when you multiply, you have to take that into account. So 9 times u becomes 9u, and then 9 times negative 11 is negative 99. And that is our answer there. You can't combine them because one has a u and one doesn't, unlike terms. Let's go down here where we have another star, okay? And here you're solving for u. We're following the directions that are given to us. Usually if I'm solving and I see an equal sign, I'll put a little line there to show that what happens on one side you have to do on the other side. So if you're solving for u here, let's get rid of this positive 5, subtract 5 from both sides. You should have definitely done this in math, the earlier maths, or if you tested right into this class, you kind of should know the concepts, okay? And then negative 5 and negative 9 become negative 14 when you combine them. So that is u by itself. If you're solving for u, once you get u by itself, you're done, okay? For this one, oh, let's go to this one, sorry. Solve for v. Same thing, we're getting v by itself. Let's add 8. If you add 8 over here, gotta add 8 over here, okay? So 8 minus 4 becomes positive 4, and that's going to be v by itself. And when v is by itself, you have solved for v, right? So now we're here, you're solving for x. It's the very same concept. Just has decimals, which is fine because we have a nice calculator that can help us. Okay, I'm getting rid of this number that's on the same side of x because remember, you're trying to get x by itself, and that is super important for you to understand what you're trying to do. All right, so now I have my calculator. I'm going to put in there 6.82 plus 7.37, and I'm going to get my answer as 14.19. Okay, so 14.19 is my answer. How do I know? Because x is by itself. So if it says solve for x and x is by itself, then you are done. You solve for x. And this one is not as hard as you would think. Simplify your answers as much as possible. If you have one of these nice little handy dandy calculators, your answer can actually come out as a fraction. I'm going to show you how to do that. Now, you're going to solve this problem like we just solved all the rest of them, okay? We're getting v by itself. Although, even though it's a fraction, it's still numbers. These are just numbers. So we're going to subtract 3 over 5 from both sides because we want to get v by itself. And if it's positive, we're going to do the opposite. So plus, we're going to subtract. And if you subtract, you have to subtract on both sides of the equal sign. So this now becomes v equals, and I have 1/2 minus 3/5. Now, this is how I'm going to do this on this calculator, okay? I'm going to show you how to do this. So on this particular calculator, you can add, multiply, divide fractions and get an answer that is a fraction. And I'm going to show you how to do it. So you're going to 1/2, and instead of 1 divided by 2 here, you are going to push this little a. This is going to be your little friend. I tell you, it is going to be your friend. you're going to push this little A, B, C button. It's right above sign. Okay, you're going to push that instead of the division, and then you're going to say 1/2 that way. Minus, okay, remember when you have that negative here, that means minus 3/5. So 3, and then I'm going to push that little AB button right there, and then it's going to give you that little backwards L, and then a 5. Okay, so that's what it looks like, and then I'm going to push enter. As you see, your answer comes out as a fraction, -1/10, and it's simplified. Okay, -1/10. So this thing, I'm telling you, this calculator is so worth it. Okay, very much worth the $12 if you can do that. All right, so that is, and I put that down here, b equals -1/10. That is our day 2 notes for unit 4.